In this project, I'm thinking about the intracranial aneurysm segmentation using deep neural network. Intracranial aneurysms is an abnormal focal dilation of an artery in the brain that is caused by the weakening of the blood vessel wall. Generally, 1 to 5% of the population involved in aneurysms, brain aneurysms. Intracranial aneurysms can be classified and categorized in different ways, such as size, shape, location. There are different types of aneurysms, such as fusiform and secular aneurysms, where the first one is less common. Also, aneurysms can be located on posterior or anterior arteries. About the imaging, three different modalities in imaging have been proposed for the DSA, CTA, and MRI. While DSA, as the gold standard, is an invasive scanning, CTA and MRI are more popular to the researchers. Recently, deep neural networks have shown great potential for the medical images analysis, especially for the segmentation task. However, the main problem of deep learning model is that it depends on dataset properties and hardware configurations. It means that by changing the dataset, you have to change many things inside the model, from the network topology and architecture, the some hyperparameters such as the patch size and batch size, and doing some pre-processing steps. To address the problem, nnU-Net has been proposed. nnU-Net is a deep learning segmentation framework that automatically configures itself for different parts: pre-processing, architecture, training, and post-processing. As you can see in the image, training data and dataset will be given to the model, but before the process, it should be passed in different steps. The most important part of the nnU-Net is pre-processing steps, where nnU-Net is doing some important pre-processing steps, including resembling, image target spacing, and intensity normalization, plus data augmentation. Generally, nnU-Net uses three models: 2D unit, 3D unit, and 3D cascade units. You can see the picture. The 3D fMRI images given to the model, but some pre-processing steps will be done. In addition, in this work, we focus on the consideration of different loss functions and the performance of this nnU-Net. As you know, loss function is one of the most important sections of a deep learning model that say different point of view for capturing different part of the image. Generally, we have distribution-based and region-based loss. However, in this task, we try to combine different distribution region-based loss functions together and to see the results. Here, we use dice, cross entropy, focal loss, Tversky loss, and top K loss. Some of these loss functions are the general loss functions. Some of them are totally dedicated for the imbalance data problem. And you can see on the left side, you can see we run the model, the nnU-Net, for 5 folds, 3 metrics, and 8 different hybrid loss functions on the ADAM dataset. The ADAM dataset is a public MRI dataset including 113 images of the top MRI dataset and also a structured MRI. And finally, after running the model in different cases, you can see the best model is the weighted dice top K cross entropy loss function that got the best results for the dice, and the overall rank it got the best overall rank too. And this is the training error and test error and validation score of 8 different loss functions on 5 folds. As you can see, this is the output of the double-line unit for the segmentation of the intracranial aneurysms. You can see the red side, the red pixels are the aneurysms that have been predicted by the model. At the last slide, very small aneurysms and uncommon and irregular shaped aneurysms are the most challenging issues and limitations in the task of intracranial aneurysm segmentation. Thank you very much.